Every time you use an AI, you're talking to something that's never lived a single day in its life. It's never been hungry. It's never been heartbroken. It's never watched a sunset or stubbed its toe or had a conversation over coffee. And yet, it can talk about all of those things fluently, convincingly, and sometimes beautifully. The answer is training. And once you understand what that actually means, the way you think about AI will never be the same. So here's what training actually means. AI is not programmed in the way traditional software is. When a developer builds a calculator app, for example, they write rules. Every behavior is spelled out explicitly. Well, AI does not work like that. Instead of writing rules, we show AI examples. Millions of them, billions of them, and we let it figure out the patterns on its own. Imagine that you wanted to teach a child what a dog looked like. You could write a rule book: 4 legs, fur, tail, barks. If you have a Great Dane, it'll knock you over occasionally. But that breaks down fast. What about a 3-legged dog? Or a hairless breed? So instead, you show the child thousands of pictures. This is a dog. That's a dog. Dog. Not a dog. Dog. Eventually, the child will build an internal sense of what makes something a dog. Not from rules, but from patterns. And that's exactly what happens when we train an AI language model. Except instead of pictures of dogs, we're feeding it language. Enormous amounts of language. Well, let's talk about where the data comes from. We're talking about a significant portion of the written internet. Blog posts, news articles, Wikipedia, books, academic papers, Reddit threads, code repositories and forums, comments, product reviews, hundreds of billions of words, possibly trillions for the largest models. Before any of that gets fed to the AI, though, humans and automated systems will clean it. They'll filter out spams and remove duplicates, and they'll cut low-quality content out, because garbage in, garbage out. If you train a model on bad data, you get a bad model. And there's something else hiding in that data. All of that text was written by humans, and humans have biases, conscious and unconscious. Assumptions about gender, race, culture, what's normal, what's important. And the AI will absorb all of that. Not because anyone intended it, but because it's learning from us, inheriting our patterns, including the ones we're not proud of. One of the big questions that people will ask is AI going to take our jobs? If AI can learn to write and to code, and to design, to analyze, what does that mean for the people who do those things for a living? AI is very good at tasks that are repetitive, pattern-based, and well-defined. So things like data entry and basic image editing, formulaic content, common customer service questions. Those jobs, things that do that, they're genuinely at risk. But what AI is not good at least not yet, and arguably not ever in the same way, are things that require judgment, lived experience, emotional intelligence, and genuine creativity. The kind of creativity that comes from having a perspective, having lived something. What we're more likely to see isn't machines replacing humans wholesale, but workflows changing. The person who used to spend 8 hours on a task that AI can now do in 20 minutes, well, their job description's going to change. What they're valued for shifts. The people most at risk are doing generic, commoditized work. The people potentially most empowered are those with a strong, distinctive voice, because AI becomes a tool in their hands rather than a replacement for their hands. Let's talk about what actually happens during training. The training process works through a very simple task, repeated almost an incomprehensible number of times. The AI looks at a sequence of words and tries to predict what word comes next. That's it. The cat sat on a blank. What comes next? Well, AI will make a guess, and we'll check if that guess is right, and if it's wrong, we make tiny adjustments to the model's internal settings, nudging it towards a more accurate answer next time. Those internal settings are called parameters, or weights. The large language models might have hundreds of billions of them. Each one is like a dial that gets tuned during training. The whole process is about finding the exact combination of dial positions that makes the model good at predicting language. The technique for making those adjustments is called backpropagation, a mathematical process that figures out which dials contribute to a wrong answer and then adjusts them accordingly. Think of it like a coach watching a game tape and saying, "Here's exactly what went wrong and here's how to fix it." You do this billions of times and something remarkable happens. The model doesn't just learn how to predict words, it picks up on deeper structure, grammar and logic, facts about the world, cause and effect, narrative structure, even tone and style. Not because anyone taught it those things directly, but because those patterns are embedded in the language it was trained on. Training a large AI model doesn't happen on your laptop. It happens in massive data centers running on thousands of specialized processors working in parallel around the clock. A single training run can take weeks. The electricity cost alone can run into the millions of dollars. The total compute cost can reach into the tens or hundreds of millions. This is why only a handful of organizations in the world can build frontier AI models from scratch. Well, after all of the weeks of computation and billions of examples, what you end up with is a file. A very large file, full of numbers. And those numbers are weights that define everything the model knows about words and how it behaves. All human language is compressed into math. Another big question that people have is what happens to your data? When you use an AI tool, typing prompts, uploading images, having conversations, where does that information go? Is it being used to train the next version of the model? The honest answer is, it depends entirely on the tool and the company. Some AI companies use conversations to improve their models unless you opt out. You'll find that in your privacy settings. But some offer paid tiers where your data is not used for training. Enterprise versions typically guarantee that your data stays private. A good rule of thumb is don't put sensitive information into a free AI tool. Your medical details, financial information, social security numbers, passwords, confidential business data, none of that belongs in a chat window with a free AI service. Not because the AI or the company is malicious, but because you often don't fully control where that data goes after you hit send. You need to read the privacy policy of any tool you use regularly. Look specifically for whether your inputs are used for training and whether there's an opt-out, and understand the difference between training data and conversation logs. Your conversations may be stored temporarily for safety reasons, even if not used for training. Both matter, but they're different concerns. Treat a free AI tool the way you'd treat a public forum. So the next time you go to type a message into an AI and it responds, what's actually happening is that you're interacting with something that was built by reading almost everything humanity has written, finding the patterns underneath it all and learning to speak from those patterns. It's never experienced the world, but it's read almost everything we've ever said about it. And that's either a remarkable technological achievement or one of the stranger things our species has ever done. Probably both.
Now that you know how AI learns, here's the part that should make you pause. The very same process that makes AI so powerful is also why AI will look you in the eye and confidently tell you something completely wrong. That's in the next video. And honestly, it might change the way you use these tools.